Hey guys, I'm going to walk you through the second part of the lab, which is about blood hitting a surface at an angle. So the first part of the lab, we dropped blood straight down, which would simulate maybe someone who's bleeding and just walking, and the blood is dripping straight down. Today's investigation looks at what blood would look like if it hits a surface at an angle. So if there's a gunshot or if someone is hit with something and blood splatters off of them onto a surface, it's probably going to hit at an angle. So there's a way that you can look at a drop of blood and calculate what angle that blood hit at. So that would help a forensic scientist kind of recreate the scene. All right, so you have your data table open. What we did was take the paper, instead of throwing blood at a surface at an angle, what we did was we angled the surface and dropped the blood straight down to simulate it. So the first angle in your data table is 90 degrees. So that is actually, we're considering straight down, perpendicular. So that was just like the first part of the lab, it was dripped straight down. All right, so I'm gonna show you, well actually, so then for the rest of them, the angle is the angle off of 90 degrees. So this would be considered 90 degrees. So the 15-degree angle would be 15 degrees off of 90. It's kind of hard to see in the video. All right, so 15 degrees, 30 degrees, 45 would be halfway, and then 60, and then 75 is the shallowest angle. So you're going to see the most elongated blood drop with that angle. All right, let me put this down. Flip it around. So I'm going to hold the ruler up to each blood drop, and you are going to read it, and you're going to get the length and the width of each blood drop. So what I did was I drew little markings from where you want to measure. So with the really elongated blood drops, I can get closer. You don't want to measure, I just used regular computer paper and it caused the blood to kind of expand off of the original drop. So you don't want to measure those spikes, is what they're called, or projections. You just want to measure the blood drop. So let's start with 90 degrees. We're measuring in millimeters. Okay, so there's your width for 90 degrees. There's your length. And you can pause the video as we go so that you can read the ruler. Remember, you're measuring millimeters as the smallest line. So 1 centimeter has 10 millimeters in it. Okay, I think 75 degrees is next on your data table. So we'll go down to that one. Things in the way here. All right, here's your width and your length. Okay, 60 degrees. Here's your width. Here's your length. 45, here's your width. Remember, you're only measuring from the black lines. Here's your length. .30 degrees, here's your width. Here's your length. Last one, 15 degrees, here's your width. Here's your length. Okay, so you might have to go back and rewatch this video because I also want you to take observations about what the drop looked like. So that's where you can talk about the little projections, the tail. So notice when you measure drops at an angle, you don't include the tail. Okay, that's it for part 1.